Welcome to This Explainer, where we're diving into the high-stakes, mega-engineering world of offshore energy. Today, we're answering one fundamental question, the objective of drilling, or simply put, why we actually have to drill. Let's establish the core conflict right out of the gate. Geologists can look at massive amounts of seismic data and tell you with a lot of confidence that there is probably oil down there. Probably. But as you know, probably does not equal definitely. And in this industry, that one single word has literally cost companies billions of dollars. The only way to turn a probably into a definitely is to go ahead, put a hole in the ground, and look for yourself. Well, here's the reality of data interpretation. The raw data that geophysicists gather, it's basically useless without some really careful interpretation. It's much like putting together a giant puzzle. They use every available source to build a model of the rock layers buried deep underground. But no matter how incredibly sophisticated that model is, it is still just an educated guess until you physically prove it's there. And that brings us to what we call the funnel of certainty. The whole industry has to systematically narrow down this massive mountain of uncertainty. You start off with phase 1, an initial guess. Then phase 2, you build a sophisticated seismic model. But then, phase 3, you actually have to drill. Because only after you drill do you finally reach phase 4, which is confirmed data. Literally every single method used before that drill bit actually touches the rock is just an inference. Drilling is the hard physical verification. Think of it like this. A seismic model is kind of like a doctor giving you an X-ray. Now, the X-ray gives a really strong hint that something is going on in there. But a biopsy, that's the only way to completely confirm the diagnosis. Drilling is essentially the biopsy of the Earth. It takes an interpreted, theoretical subsurface model and converts it into a physical, verifiable dataset. We're talking real rock, real fluid, and real pressure. Now, don't get me wrong, remote sensing technology has evolved incredibly over the years. One of the absolute biggest breakthroughs has been three-dimensional seismic imaging. Using seismic field data, geophysicists can now generate a full 3D picture of those underground formations. It lets us see the actual composition of the Earth's crust in a specific area, which, is tremendously useful for estimating the probability of a reservoir existing. In fact, using 3D seismic technology has been estimated to increase the likelihood of successfully locating a reservoir by a staggering 50%. That is a massive leap forward from the old days. But even with a 50% boost in your success rate, it still leaves a huge, incredibly expensive margin of error sitting right there on the table. You might also hear about a technique called direct detection. Back in the mid-70s, it was discovered that these white bands on seismic recording strips, they call them bright spots, could indicate porous rock that was packed with natural gas. In the data, it literally looks like the gas was just screaming at you. But here's the big warning label: those spots can lie. Many of these bright spots don't actually contain any hydrocarbons at all, so it's simply not a completely reliable method. Which brings us right back to our core message. Drilling is the physical act of boring a wellbore down to a target rock formation. Its job is singular, and it's absolutely vital. It makes physical contact to confirm exactly what is underground. It tests the quality, and if it turns out to be commercially viable, it gives those hydrocarbons a path to actually flow up to the surface. It's the exact same hole doing two crucial jobs, because absolutely no remote sensing technology, no matter how advanced, can sample fluid or prove a flow rate from thousands of feet up above. So, quick check here. If your world-class seismic model shows a 90% chance of success, why would a company still drop upwards of $100 million to drill a hole just to confirm it? Well, it's because a 10% chance of being wrong is totally unacceptable when you look at the big picture. And man, what a big picture it is. The stakes are monumental. Spending $100 million on an exploration drill is actually cheap. It's just necessary insurance against making a catastrophic $2 billion mistake in full field development. Companies that try to skip the appraisal drilling phase and jump straight to development based on seismic data alone, well, they have a very well-documented history of massive, catastrophic write-offs. You simply cannot make a multi-billion-dollar decision based on the word probably. Which leads us to our final takeaway for this part of the explainer. In this industry, physical confirmation is absolutely everything. No well means no proof. We've established exactly why drilling exists, because literally nothing else can physically verify the subsurface. But if a single drive hole can cost $150 million and only tell you, nope, the oil isn't here, what does that verification actually cost per hour when you're running a $400 million machine? Well, that is exactly what we are going to uncover in part 2.